solving other equations. And this is the second set of videos talking about other types of equations. The first set of videos covered how to solve all different types of polynomial equations. This set of videos is going to talk about basically any other type of equation that we might see. So these include rational equations. Remember that word rational has that keyword of ratio in it, meaning there is fractions in that type of equation. We learned how to solve those back in week 6, assignment number 1. The key to solving rational equations was what I like to call my magic trick, and that magic trick was to multiply everything in the equation by the LCD, and by LCD I mean least common denominator, because when you did that it got rid of all of the denominators, meaning it got rid of the fractions, so it just broke it down to a regular polynomial equation. Other type of equations that we've learned how to solve so far are quadratic lookalikes, and we learned how to solve those as the first assignment of this week. One way that we did it was we let u substitute in for whatever it needed to be for that middle variable here, so that transformed it into an exact quadratic equation. Or if you didn't want to do that, you could have just done it straightforward with factoring in the quadratic formula. Now these are technically polynomial equations, but I put them into the other group because it takes a little bit of manipulation to get them there. The last type of equations that we need to learn how to solve is radical equations. And by radical, I mean square roots, or cube roots, or any type of root, to be honest. So we need to learn how to solve these types of equations, and that's what this set of videos is over. Okay, the steps to solving these is to isolate the root or isolate the radical. If there's more than one, usually you want to try and isolate the more complicated radical. After you have that radical isolated, what you want to do is power both sides. Now I put those stars around that word power because that's not really a mathematical vocabulary word, but it makes the most sense to students, so that's why I've listed it like that. Now be aware, because you might need to FOIL on one or both sides for that to happen. Then, at that point, hopefully you have gotten rid of your radical, so you can just solve the remaining polynomial equation that you have at this point. And if you haven't got rid of your radical, then basically you need to repeat steps 1 and 2 before you move on. Once you have it down to your polynomial, you can just solve it from there, and then on these problems you will definitely need to check, especially the ones that you took to an even power in step number 2. And the reason for that is because when you take things to even powers, those negatives end up canceling out, and sometimes that makes the problem incorrect. So you have to fully check every answer for these problems. Okay, let's see an example to this. And I'm starting with my easiest example here. The cube root of 5x minus 2 is equal to negative 3. So step number 1 is to isolate one of your radicals. In this problem, we only have one radical, and it is already isolated, meaning there is nothing else affecting this radical on the left-hand side of my equation. So step number 1 is done. Step number 2 means I need to power both sides. Now, the power that I'm going to use here is a 3, because that's going to cancel out my cube root. If I do it on one side, then I need to do it on the other side as well. On my left, my cube and my cube root cancels out, leaving me with just 5x minus 2. So there's no more root involved. On the right, I have negative 3 to the third power, and that simplifies to negative 27. From here, this is a linear equation or a degree 1 type of equation. So I just solved this equation by isolating your variable. So I move 2 to the other side. Gives me 5x is equal to negative 25. And then divide by 5 on both sides. And that gives me the answer of x is equal to negative 5. Before I box this answer, let me check. So I'm asking myself, does the cube root of 5 times my x, which I just learned is negative 5, minus 2, we want to know, does that actually equal the negative 3 that we expected? So simplifying the inside of your equation, of your root first, gives you the cube root of negative 25 minus 2. And that gives you the cube root of negative 27. And of course, that is equal to negative 3. So this is an okay final answer. Or if it wants the solution set, you just put that answer in braces. This is where I'm going to stop this video, and in the next video I'm going to do a few more examples of solving radical equations.